Not all that impressive. One could wonder where animals go from here. With a report on where animals went from there, we return to Leptoceratops, who is now reporting from the beginning of the Ediacaran period. Leptoceratops, what do you see? Right. What you're observing now are the first moving animals. These animals actually have muscle tissue and the nervous tissue which can command it, so they are capable of moving. They are very similar to jellyfish and corals and hydra and sea pens today. These are cnidarians. Yes, I can clearly see that they are moving. Can you ask one to come on over here so that they can be interviewed? Well, they can't really come over for an interview because they don't really have that kind of control over their muscles. See, while they do have a nervous system, they don't have a brain. They just have a nerve net of loose nerve cells, which then governs a number of reflexes. But conscious control over muscles, well, that's just something that these brainless animals don't have. Their nervous system, does have the same ability to conduct electricity as ours, and they do have senses, such as they do have primitive eyes, but they do not have a brain. You mentioned they had eyes. Can they see me right now through the screen? Well, it can't really see you because these eyes are more for just the perception of light versus dark and knowing which way is up. They're not really for vision in the way that you understand it. But there are some advances. So, for example, they do possess true gonads, specialized areas which produce the sex cells, unlike the sponges, and they do make certain hormones which are also found in the higher animals, such as the homologue of the hormone oxytocin is something that these animals make. The homologue of oxytocin? When I hear that, I think of oxytocin being the signal in higher animals for orgasm, or even what those mammals use for live birth and for milk letdown. And you're saying that it was things like this that invented oxytocin? Is there anything else there that you can show me other than these jellyfish-like looking things? Here at the beginning of the Ediacaran period, a little over 600 million years ago, there isn't much else to see. These cnidarians, the jellyfish relatives and the relatives of corals and sea pens, they are the most abundant and dominant animals in the world as far as fossils tell us. Later, certainly jellyfish and corals survive, but never again in Earth's history do they dominate the way they do at the beginning of the Ediacaran period. Tell me, why is this weird bunch of animals known as the Ediacaran fauna? Right. These animals were first named for the Ediacaran Hills of Australia where their first fossils were found. We now know that they existed all over the world and are considered so important that a new geologic period, the Ediacaran period, was named after these Ediacaran animals. They were the first animals with muscular systems and nervous systems. Prior to them, only sponges are known to have existed. It was once thought that the animals appeared suddenly in the Cambrian period, which began 542 million years ago. But we now know that much of animal complexity evolved in the period prior to that, the Ediacaran period, and these animals evolved many of the advanced features that later animals would exploit.